gives us mild steels. It is used in making boiler plates, steel joints, angles, drop forgings. Medium carbon steel. In medium carbon steel, the constituent of carbon is 0.3 to 0.6%. The medium carbon steel is used in making shafts, high tensile tubes, wires, fish plates, railway wheels, agriculture tools. High carbon steel. High carbon steels, there is percentage of carbon is 0.6 to 1.4%. The high carbon steel is used in dies, springs, chisels, woodworking tools, razors, brochures and drills. Non-ferrous alloys. Alloys of non-ferrous metals like aluminum, copper, zinc, tin, etc. are known as non-ferrous alloys. Iron is not used in making these alloys. Some important non-ferrous alloys are aluminum alloys, copper and zinc alloys, which is also known as brasses, copper and tin alloys, which is known as bronzes. Non-ferrous alloys they are obtained from the aluminum, copper, zinc, tin, and there is no presence of iron in them. Iron is not used in making these alloys. The properties of steel's ferrous alloys determined by dispersion strength depend upon the amount, size, shape and distribution of cementite. These factors are controlled by alloying and heat treatment, which is further normalizing, annealing, quenching and tempering. It is a heat treatment. We will get different type of iron from mixing iron with carbon. So we will get scissors, blades, hammers. So different type of material is obtained by using heat treatment. That heat treatment is known as normalizing, annealing, quenching and tempering. Specific effect with different elements. When chromium is used with the iron, it is added in proportion up to 18%. It improves hardness and toughness. Nickel, it improves tensile strength, ductility, toughness, elasticity and heat and cross ion resistance. So they are sometimes used as resistors. Manganese, it increases strength and toughness plus brittleness. Vanadium, it gives us tensile strength, ductility and shock resistance. When we are mixing vanadium with the iron and carbon, it increases the tensile strength, ductility and shock resistance. Molybdenum, when we are adding molybdenum with the iron, it strengthens at elevated temperature and it acts as cross ion resistance. Similarly, tungsten gives us toughness and shock resistance. When silicon is added to the iron, it increases the hardness, eliminates oxygen and improves the resistance from oxygen. It is used for making cores of transformers and electromagnets. Properties of alloys. These have high electrical and thermal conductivity. These have highly good corrosion resistance. These have highly ductile and malleable. These can be readily fabricated. These can good castability and mechanizability. These can be easily worked in cold and hot conditions. So, properties of the alloys are better than the parent metals. They have high electrical and thermal conductivity. They have highly good corrosion resistance. They have highly ductile and malleable. They can be readily fabricated. They can good castability and mechanizability. These can be easily worked in cold and hot conditions. Alloys are mostly used in our daily life. Pure metals are not possess the required properties for some definite purpose. Pure metals are generally get corroded easily, but these alloys they don't corrode. Alloys are made to get required properties. Alloys have good properties from the metals by these are made. For example, some alloys have greater strength more than these metals from which they are made, and some alloys have greater melting points from the metal from which they are made. Due to good strength and hardness, these are mostly used in making homely things, agriculture equipments, and industrial machines. There are some non-ferrous alloys, examples of non-ferrous alloys. In German silver, the constituents are copper, zinc, and nickel. This German silver is used for making utensils, bolts, screws, cutlery, decorative articles. German silver has characteristic ductility, malleable, and looks like silver. It possesses good strength and corrosion resistance to salt water. Similarly, brass or Tauben bronze, it has constituent copper 70%, zinc 29%, and tin is 1%. It possesses high corrosion and abrasion resistance. This is used for propellers and marine work. Bronze is generally obtained by mixing copper with tin. So here copper is 80 to 95% and tin is 20 to 5%. So there is no fixed ratio. The ratio can vary. The bronze are tough, strong, and they are corrosion resistant and can be easily casted and machined. Coinage bronze. Coinage bronze is obtained by mixing copper and tin. Here the composition of coinage bronze is approximately 90% copper and 10% tin. It is soft, ductile, and durable. It is used for making coins. Gunmetal. The composition of the gunmetal is copper 88%, tin 10%, and zinc is 2%. It is hard, tough, and strong to resist the forces of explosion. The gunmetal is used for making gun barrels, water fittings, heavy load bearings, and parts of high pressure steam plants. Bell metals. The composition of the bell metal is copper approximately 70% and tin is 30%. It is hard, brittle, and sonorous. It is used for making bells. Nickel bronze. The composition of nickel bronze is copper 90%, nickel 9%, and iron is 1%. They are hard and better corrosion resistance than copper. It is used for rolling purpose, valves, and general purpose semi-hard bearings. Composite materials. These materials are usually man-made. They are a three-dimensional combination of at least two chemically distinct materials with a distinct interface by separating the components created to obtain properties that cannot be achieved by any of the components acting alone. So these are man-made materials. They are three-dimensional combination of at least two chemically distinct materials with a distinct interface separating the components created to obtain properties that cannot be achieved by any of the components acting alone. Composites are combination of two materials in which one of the material called reinforcing phase is in the form of fibers, sheets or particles, and is embedded in other materials called the matrix phase. The reinforcing material and the matrix material can be metal, ceramic, or polymer. A composite is one composed of two distinct regions, a matrix and a reinforced phase. Matrix phase, it is continuous phase, the primary phase. It holds the dispersed phase and shares a load with it. Dispersed phase, the second phase or phases, it is embedded in the matrix in a continuous discontinuous form. Dispersed phase is usually stronger than the matrix, therefore it is sometimes called reinforcing phase. So composition of the composite material is a composite is one of the composed of two distinct regions, a matrix and a reinforced phase. Matrix composite are composed of a metallic matrix, aluminum, magnesium, iron, cobalt, and copper, and dispersed ceramic, oxide, carbides, or metallic. Ceramic matrix composites are composed of a ceramic matrix and embedded fibers of other ceramic materials. Dispersed phase. Okay, now my time is over. Okay, thank you.